Right, it feels like we're ready to make a start. Doors are almost closed. If anyone wants to come even further, feel free to. This is a reserve, but I'm not sure for whom. Yeah, just welcome. My name is Igor Andreoni. I'm one of the two co-chairs of the Rubin Transients and Variable Star Science collaboration. I have the privilege of co-chairing with Sara Bonito. Here we have Sara's photo. And I have to update our affiliation, so ignore that. But for any reason you would like to get more involved in TVS or involved at all, you have questions, you have, I'm just curious, anything TVS, feel free to reach out to Sara, reach out to me via Slack, emails, really any way. It's always a good idea. Before we go in the weeds, however, some of what will be the usual reminders, since you will see them at the beginning of every session of the workshop all the way until Friday afternoon. The reason why you will see it over and over again is because it's very important. There is a code of conduct. No bullying, harassment, or any inappropriate conduct will be tolerated. If you experience or witness anything that you feel like should be reported, there are resources such as contacts that you see on the screen, Sandrine, Federica, and Jeff. Reach out to them, start a conversation. Hopefully we will make it always a healthy, constructive work environment. You can also see protocols for COVID-19 precautions. Beware if people have social batteries. If they don't want to be talked to, maybe limit interaction. Not everyone experiences things the same way. And we embrace this type of diversity. And as an additional reminder, we do have a lot of people connected on Zoom. I don't know in this session, but it looks like the screen is pretty full. So when you talk, first of all, please make sure you're speaking in a microphone. I don't know if will be actually one that goes around, otherwise we can borrow the one I'm wearing. And also, please just say your name before talking, even if you are here in person, so that people online know who is talking to them. Talking about diversity, TVS is inherently diverse, given that, well, people come from, I haven't counted how many countries exactly, but we're pretty much a global collaboration. Numbers have skyrocketed. It's kind of hard actually to keep up with the onboarding. If some of you is waiting to be onboarded, thank you for your patience, and we will get to it. But we have more than 770 members now, very widespread across the globe. And I don't want to take too much of time with this introduction. I just would like to make sure people in TVS remind themselves of this, and new people who are not familiar with TVS know that we have a number of resources that people can access. Those include the website. Just Google LSST TVS, should be the first suggestion that comes up. We have the Slack within the LSST DA Slack workspace. We have channels for TVS. And in fact, when you browse new channels, just type in TVS. You will see all the channels that were created for various TVS activities. And on top of that, you can check out the colloquia and other type of material that is uploaded periodically on YouTube. And of course, stay tuned for activities, various resources, conferences that are organized. And in a few minutes, I will let actually Sara present some information about an upcoming LSST TVS meeting. Not just we are many people from many corners of the world. We come from very diverse scientific backgrounds. And in a way, it's challenging because we have to be a home to people who are excited about transients and variables in our galaxy, the cosmic distances. They use very different methods, but we try to make it happen, I think, quite successfully. If you feel lost, it's okay. You can always talk to people, talk to Sara and me, talk to your favorite person within TVS, but also you can refer to the TVS roadmap. It's this document published by Kelly Hambleton et al. A few years ago, and keep up to date with the literature. Like a lot of papers are being published that represent very well the mission of what we're doing within TVS. Part of the trick that we're using to, again, be a home to everyone is divide and conquer. So we divide ourselves in subgroups, but typically the subgroups have a scientific common theme, and then task forces, which sometimes they last for 8 years, but typically are just 1-year efforts, and often across collaboration, not just within TVS. And this is a place where people can make concrete contribution to the whole LSST ecosystem beyond the scope of what we're doing in LSST. And I think actually now I will get a microphone. Thank you. And I would like to open the floor in case there is anyone, either in person or online, that belongs or chairs one of these subgroup or task forces that would like to share updates, news, or anything they would like to share with more people than those that typically show up at our bi-weekly meetings. So before going online, anyone in the room would like to give quick updates or anything exciting happening? And as a reminder, please introduce yourself.
Hi, everyone. Is this on? Okay, hopefully you can hear me if you're online.
Can people online please confirm if they can hear Shar talking? Oh, good.
Yes, I can hear.
Nice. Okay, there's just not a speaker in the room, so we can't tell. Hi, this is Shar from the University of Delaware. I am the subgroup coordinator for the Fast Transient subgroup. And our update is that we're revamping our Fast Transient metrics project in the fall. You will hear from us. So especially as the survey strategy is continuing to be adjusted, we can get all of the science related to fast transients in there. And if anyone wants to chat with me more about that, find me sometime this week.
Hello. So hello everyone. I'm Siddharth Shaini, or Sid. I'm also from the University of Delaware, and I am the co-coordinator of TVS Anomalies, where we are focusing on anomaly detection in the context of TVs to find interesting transients and variables. And we've been working with the ISSC, which is the Informatics and Statistics Science Collaboration, to sort of take a lot of different methods and see if we can recover historical anomalies. And so something we're actively working on is we are right now working on collecting sort of these anomalies and also sort of building this data set of historical anomalies. And a few months ago, I think Shah had posted on the TVS Slack as well about a form. If you are interested, like if you have an object you're interested in and you know that it is an anomaly, please fill that form out, and I can share that again as well. And so we're just curating a lot of this, and with TP2 we probably will meet up and try some hacks. So if you're interested in any of that, please, you're welcome to join us. And the channel in Slack is TVS-anomalies. Thank you.
If I may, I think this is an extremely clever idea to do this work. So thank you for spearheading it.
Hi, everyone. I'm Riley Clark. I'm at the National University of Singapore, and I'm also the coordinator of the TVS Software Task Force. So one of the objectives of this task force is to identify currently what software projects and are required to accomplish the TVS related science for Rubin. And so to that end, we've been working on creating a register of TVS software projects that exists on the TVS website as a place where anyone can go and basically post a short description of their project. And so anyone visiting the website can then just see a broad overview of what kinds of projects the science collaboration is working on. And then the other thing that we do is we also run software training workshops, basically like workshops designed to train astronomers to develop software like industry professionals. And we are, for the first time, running one of those workshops at this Rubin CW on Friday at 1:30. So if that interests you, please consider attending. So thanks.
Hi, I'm Vincenzo Petricca from INAF Napoli, and I talk of the data preview task force that I am sharing together with Sara Bonito, who's online. Unfortunately, I don't have any exciting updates to tell you, but think about it as an open call for all TVS members, because data preview 2 is coming out today, and there are many things that we can do. So if you have any ideas, please reach out and let's discuss what we could do together in the next few months.
Vincenzo, since I have you here, is there anyone online that would like to speak? Vincenzo is kindly agreed to help check in. If anyone online wants to contribute, and whenever he speaks up about that, we'll be happy to give them the floor.
Hi, this is Natasha Abrams from the microlensing subgroup. I wanted to say we've been doing a lot of work in support of alerts for microlensing. We have a filter up and running on the Antares broker that we're improving as there's more alerts that are coming in. There's a lot of simulation work being done, primarily led by Daniel Godinez, to be able to train some machine learning based filters for microlensing, which is a data set that he intends to make open to the public. Yeah.
Thanks, Natasha. Anyone else from the room or from the virtual space? Well, if not, then later there will also be an opportunity for everyone, thank you, to chime in, especially in the discussion part towards the end of our agenda. The agenda has evolved in an interesting way. It was pretty empty until last week, and then it was overwhelmingly full. Part of the reason is because we wanted, as always, to provide a place where people can speak up, can discuss anything TVS. But also we noticed, together with this Target of Opportunity Advisory Board and people from the Rubin project, that there was no dedicated room to discuss the Target of Opportunity program, which means essentially you stop all the regular survey operations and you move the telescope towards sources of interest. In this case, sources that require wide field of the observations in order to be imaged. We offered essentially to provide some time for that type of discussion during this session. Part of the reason being ZTF members, I'm in too many collaboration. TVS members are really, really involved in this type of effort. Before going there, though, and concluding then with more discussion on where we are at with the survey strategy, the simulation and actuation, I would like to give the floor to Sara. Sara Bonito is my co-chair. She's online now. Sara, can you hear me correctly? Can you please speak up if you're there?
Yeah. Yes, can you hear me?
Yes. Go for it. I'll be able to see the slides now, and let me know whether you want me to move.
With the connection? Yes, thank you. So we would like to welcome all of you to a meeting focused on transient variable star science collaboration. It will be held in Palermo in Italy, where I am located, and it will be on the third week awarded with grants, both from Italian National Institute for Astrophysics, INAF, Director Discovery. You can see here a list of people involved in preparation for the Transient Variable Star Science Collaboration Meeting, Verasi Rubin Observatory, Legacy Survey Space and Time Data Preview to Exploitation. So it is very timely for us to meet in person and discuss and also use the new data. If you can go on the second slide, please. Igor, please, can you?
We are on the second slide.
Oh, thank you.
Can you see it?
It will be an internet. Yeah, I see that now. Thank you. So it will be an international meeting of our science collaboration. Of course, transient variable stars topics are also in common with other science collaborations. So everybody is welcome to from other science collaboration as well. It will be focused on the exploitation, the first early science results from Rubin LSST after first look and now with the data peer review too. And it will be a 4 days meeting with 3 morning and 3 afternoon sessions. It is designed to facilitate international participation in presence and minimize non-working day travel. And there will be also hands-on session because we want to use the notebooks and the tutorials with link frameworks and using the software that has been developed and the Rubin Science platform. And we want to use the data and to prepare a white paper as an outcome of the discussion and focusing on during that meeting. And last slide, I think, so maybe 2 more
Sara,
slides. So
the connection is very
sorry, very
so,
bad. I try without the video.
Okay, try.
So we expect to have more than 150 participants, with including senior experts, but with strong emphasis on students and early career researchers. And we will be providing financial support on request, especially. And all people from all the Rubin ecosystem will be invited from TVS and LSST Discovery Alliance and all the Rubin ecosystem parts. And please contact Igor and myself and the people that you've seen in the first slide to express your interest in attending in person or remotely the meeting, so we can define the details. And the next slide, if you can change the slide, please.
Do you want the one with the picture?
Yes, this is no, yeah.
Because they're very similar, but in one,
let's
put with you.
Yeah, it's just showing me how happy I was visiting. I was very lucky to visit Vera Rubin Observatory. This picture I have taken this picture myself in Chile. It was so exciting to hear and see the start of this amazing project. So I will stop here. Please contact and in person or the TV meeting that will be held in Palermo in December. Thank you.
Great. Thank you, Sara. Let's have a clap for Sara. Okay, so switching gear now, let's dive into the Target of Opportunity program. I will give a very brief introduction to provide you a bit with context of what's been happening over the years with this program. And then we will have Sean and Shreya telling you more about what's going on behind the scenes and the science that Rubin is already producing with TO observations. The TO program comes from far away. The possibility to interrupt the scheduler and fit in opportunistic observations has been essentially within the design from the beginning. So I think many of us are grateful for the people who built the scheduler and the system to have this vision and immediately make space for this type of capabilities. However, we always need a science driver, right? Otherwise, there is never going to be something actuated even at LSST level. So the community came together officially for the first time in 2018, writing together this white paper that was led by Raffaella Margutti. And gravitational wave follow-up was identified as the primary driver for target opportunity observations. So essentially, you may have a neutron star merger, binary black hole merger that occurs. Gravitational waves are emitted that may be detected by the LIGO and Virgo and Cagra detectors. And if and when that happens, we are informed about some typically pretty broad sky localization that we can then image with our telescope looking for electromagnetic counterparts. This effort has then been improved upon, updated, further developed by largely the same team of people, but we've been even more inclusive. And if you look at the people who signed this document, you can see people working really across the board. There's science collaboration, especially TVS and DESC. When it comes to gravitational wave follow-up, those are the communities historically more interested in it. But then we went a step further. Why limit ourselves to gravitational wave follow-up, no matter how interesting the science is? So what we have worked on in the last few years is to pull together literally the entire community and ask them, are you interested in using Rubin for TO observations? So some of the main drivers that came out at this workshop that we've organized in Berkeley, first in 2024 and then in 2026, are, well, besides gravitational waves, high energy neutrinos follow-up, and solar system science, in particular, identification of potentially hazardous asteroids were among the main additional science cases that together constitute the Rubin TO program. Probably, I think Sean will tell you more, but very much in a nutshell, whenever there is an external trigger, gravitational waves, gamma rays, neutrinos, solar system object detection, there is a fully automated system that will start changing the schedule and make it such that Rubin is then set to perform certain observations that were pre-designed. So that's why this work on creating a blueprint is so important, because we're trying to be as automatic as possible so that we can really represent an agreement that people in the community have reached, first and foremost. And also to remove responsibility on big calls from individuals versus leveraging the shared expertise of the community. If everything goes well, if the trigger is actually genuine, if no one screams that we should really stop, then observations should proceed automatically. However, there is this new organ within the LSST framework called the TO Advisory Board that within 24 hours is tasked with reviewing what's been planned by these automatic triggers, or even consider triggers that have not passed the automatic criteria. And upon discussion, perhaps we can make a recommendation to the Rubin leadership so that TOs can be activated. I say we because I'm actually co-chairing this TO advisory board together with Michael Coughlin. Maybe some of these names or all these names are familiar to you. The takeaway message is that you will have representative here from various science cases and from countries that have actively contributed to the building of the Rubin ecosystem. So France, UK, Chile, besides the US. Always feel free to reach out to people you know, or in any case, I think we will establish then a mailing list so that we can make it easy for everyone to get in touch with members of the TO advisory board. And with that, I will stop for questions before leaving the stage to Sean. I can. Thank you.
I have a loud voice.
I know, but people online will not hear you no matter how loud you are.
So I just wanted to ask, in making such decisions, and sometimes it's about volume, which critter should I follow, which should I not, and what science is it displacing? So I was just asking, I don't know all these people, what is the representation of other science on this advisory board?
So within the framework of these workshops, and then the official reports that we presented to the SCOC, the SCOC is the committee that essentially advises, doesn't decide, but advises the leadership on what to do with the telescope. Within these reports, we have identified which science cases should be prioritized at the moment. So it goes from the community to the SCOC as a committee that reviews what the community has proposed and then passes on whatever they believe is valuable. Then the leadership are the people that ultimately will make a decision. So if there are science cases that are outside the scope, at this time, they are not supposed to be pursued. Now, if something absolutely exceptional and unexpected happens, I think people here are fairly open-minded in many ways, including scientifically. And we are, I think, covering a lot of the various possibilities, including a galactic supernova, for example. These are exceptional cases that we are considering as potential targets for TOs. Every year or 2 years, we reopen the floor to suggestions. We want people to come back together and write updates to the report so that new interesting science cases can be incorporated, also depending on how the landscape shifts. Any additional questions? Vincenzo, anyone online? All right, if not, Sean, can you please join me over here?
Sure. Yeah.
Do you mind? Thank you.
Perfect. Thank you. Thanks. Appreciate it. Yeah, there should be a little slide. Yeah. You should open up in the Google. Yeah. Perfect. All right. Great. Okay. Hi. It is a pleasure to be here. My name is Sean McBride. I'm a PhD student at the University of Zurich. I worked on the summit for a little over a year working on LSST camera, and towards the second half of my time there, I shifted towards developing the TO system for Rubin. What I'd like to do here is give a brief overview of how the TO system works, what we've done so far, not too much into the science itself, and then also give just a general status update of what is supported, what is not supported in the current TO portfolio. Okay, so you've likely seen this figure many, many times before. This is a breakdown of the kinds of surveys that make up the LSST. And so, at least in terms of what we think about, in terms of the scheduling and survey strategy side of things, we have three main surveys. You have the wide, fast, deep survey, mini and micro surveys. This is like what contributes to the northern ecliptic spur here. And then also we have the deep drilling fields. TOOs comprise about 3% of the LSST total time. So this is roughly comes out to about 10 nights a year. Now, we try to make the most of our TO observations because they're very, very different from what we do in terms of what our normal observations are, our scripted observations. They require different workflows, different ways that we communicate, and different triggering mechanisms. It also requires a lot of engagement actively because these things are fast evolving, and sometimes we have to retract, sometimes we have to break rules that we've set in place before, and sometimes we have to go beyond what we would consider as standard data processing. There was a question about how TOs serve exactly the goals of the LSST and how sometimes we can, what science is at risk here. So I've shown up here the four main pillars of the LSST. If you go back to Jelko's paper that was published first in 2007 and recently into press in 2019, you'll find that it's these four pillars. And at least within the TOO program, we try to cover each of these pillars individually, and in some cases more than one time. So this encompasses all scales for astronomy, both solar system all the way up to galactic and cosmic scale. And some of these cases as well will actually serve multiple of these pillars at once. This is a high-level overview of the TOO system. I've put in my slides a link to a paper that is on arXiv right now that goes a little bit more into the technical details. The most important thing I'd like to demonstrate from this flowchart is that we make a very stark distinction between what do we trigger on and what do we do on something that we have triggered on, or our observing strategy. So the triggering criteria I'll talk about first. The way it works is we have producers or external experiments that will send out alerts. LVK, Super K, Ice Cube, all of them will send out alerts, and we're constantly listening to that at the summit. We have a low latency processing application that makes rapid decisions on does an alert packet that is sent by one of these external experiments meet our quality, our trigger criteria for Rubin to execute a TOO observation. All this happens within about 1 second. This is the route that 99% of our TOOs go through. 1% of our TOOs will actually require manual intervention. So this has to do a little bit with the Rubin TO Observer and the TO Advisory Board that Igor was talking about earlier. This group is empowered and has the technical know-how to say, this is something that, while it does not meet our standard trigger criteria, it's something we would like to go and follow up on. And we've actually already exercised this capability once before, back in November. I'll talk a little bit about that in a few minutes. Now, once we've triggered an alert, we have to now go and take the observations. And this proceeds fairly standardized, no matter if we do the manual injection or if we do the automated injection. So all of this happens within about 5 minutes. And I'll show you at least here, this is a preliminary estimate of our latency from alert receipt on Summit to first observation. And the main thing that I'll highlight is that we have two different timescales, whether or not we receive the alert during the daytime or if we receive the alert in the middle of the standard LSST observations. The difference in time here is about 5 minutes for receiving during nighttime, or 10 minutes plus the amount of time it takes us to get to sunset if we receive an alert during the daytime. So it's a very, very fast response, and this will be happening and interrupting previously scheduled LSST observations in order to take these images. So that's just an overview. I understand this flowchart can look very, very scary at times, but it's best to understand that it's really two individual questions that we're trying to answer in concert. Do we trigger on this? And once we do trigger on this, how do we image it? The Igor brought up earlier, we have a very robust and diverse team that is making sure that we're covering all different science cases for TOO science. In addition to the TO Advisory Committee, we have what was originally called a TO observer. I would like to posit that it should become a plural, TO observers, one or multiple members of Rubin project who form a team of people who can step up and on occasion inject and make decisions about the day-to-day, very short latency. Do we activate? Do we not activate? These are the people who are going to be shepherding the Rubin TO system on a day-to-day basis and interacting not only with the TO advisory committee, but with the wider scientific community as well. These are the people who will say, okay, here's an alert, it did not meet our standard trigger criteria. I'm going to work with the TO advisory committee to determine, do we trigger, do we not trigger? So we balance a lot of our automation that we do with the TO producer and this automated alert processing with this human oversight so that we're not wasting our TO time on Sky with spurious alerts and spurious observations. This is really important in order to maintain that we stay underneath the 3% allocation that we've been given for the LSST. I'll end here by talking a little bit about what we've already been able to accomplish. So we have 4 different alert classes in the TO program to date, and we've already triggered on 3 different classes themselves. 3 of them were in the early commissioning and optimization period. We had 2 gravitational wave events, one of which was right in the middle of Chilean winter. We were actually curtailed by weather from taking additional observations for S250725J. And then one was just at the end of the most recent LVK observing run. This was a subsolar mass merger candidate that Shreya is going to talk a little bit more about later today. And then we also had one that was just 2 weeks ago, high energy neutrino candidate from IceCube. That was very interesting. We spent 3 or 4 days working nonstop trying to both image and process the data from this region. And then 3 days later, we learned from IceCube that it was reclassified as a cosmic ray shower. So not astrophysical, or not extragalactic. So this is going to happen. We're going to have retractions. We're going to have instances where we start observations and then external experiments reclassified. This is a 10-year program. We're going to run into these situations more than once. Then, of course, back in July of 2025, we had the 3rd ever interstellar object that was initially identified by the Atlas array. We took targeted observations using the TOO program to get a full color profile using all of the available bands in LSST CAM. And some of these observations actually supported the first project science paper with LSST CAM. So this was a real shining accomplishment of the TO program. And I want to highlight, we have 4 TO triggers up here. 2 of them do not fall within our standard alert trigger criteria, and it required external input from a TO advisory committee to say, no, we need to observe 3i Atlas. No, we need to observe this subsolar mass gravitational wave merger candidate. So we've already demonstrated that the sociological framework that we have for the TO system, it works, and it worked extremely well. All right, the next slide here, I'll talk about, so we have 4 different alert classes. We have automated support for 2 of them already, and we're in the progress of bringing up the final 2 alert classes. Now, this is not to say that we could not trigger on a potentially hazardous asteroid, but we could not do it in an automated fashion. It would require manual injection, which is not difficult to do, but we want to move more towards a very automated setup using a predetermined set of criteria so that we can trigger, and more or less, as I like to say, we can be really observers and actually observe the system do what we want it to do. So this is the current status of things. The aim is that actually within the next 2 months, we can get these loading symbols to become green check marks. And I think that is certainly where we want to be for long term. All right, that's all that I have on the TO system. I wanted to highlight I'm giving 2 additional talks about the TO system. One is on Wednesday in this room at the same time. I'm going to be talking a little bit both with you here about what do we want to do for the early science context with the TO system. And then Thursday, I'll also be giving a plenary about some of the science goals and science things we've achieved in the first year. So thank you very much. I'm happy to take questions.
Right, any questions for Sean? Anything online? Anything in the room?
Hi, Sean. I'm Nandini Hazra from NCBJ in Warsaw. So I was wondering if you could talk a little bit about the prompt data processing for longer exposures that we've been chatting about, and it's been very interesting. So if you could just tell us something about that.
So I mentioned at the beginning that I got involved initially with Rubin as a camera scientist. And one of the things that is a part of the TO program is we really prize depth for a large area of the sky. There's two ways to do this. One is taking multiple exposures that are standard cadence and co-adding them. And then the other is to just take very, very long exposures. In the TO program case, the current prescription is 120 or 180 seconds compared to our standard 30-second exposure time. That is currently under revision, and I think there will be some revision generally from the policy standpoint to come down. What we are seeing is that as we increase the exposure time, we took an engineering data set on the summit in April 11th of this year, and I did an analysis of that showed that as we increase the exposure time by 30 seconds, you're masking, due to saturation, crosstalk, and other effects in the CCDs, you're masking 2% of the focal of each sensor additionally. So for every 30 seconds that you add, you mask another 2%. As you go to 180 seconds, that's another 10% of the CCD that you're losing. We're still trying to evaluate that, and that actually leads pretty well into what Shreya is going to talk about, which is trying to weigh that up against the next 6 months to a year of early science outcomes. So we have a good quantification of it. I think we will revise it down for the next year, but going forward, we certainly want to find a way that we can get deep enough without having to lose 10% of our CCD. So.
Any more questions for Sean? If not, let's thank him again. And the next talk will be given by Shreya Anand, who currently is a Rubin LSSTDA Catalyst Fellow. Oh, I'm sorry.
Is it this one? Okay, I think I got it. Yeah. All right. Hello, everyone. I'm Shreya Anand. As Igor mentioned, I'm an LSST Catalyst Fellow here at Stanford. And I will be talking today on behalf of the Rubin Target of Opportunity Workshop SOC Scientific Organizing Committee, including all the names listed here, about the revisions to the previous recommendations for Rubin's Target of Opportunity Scientific Program. So as Igor mentioned in his talk, we had a recent meeting at UC Berkeley for revising these previous strategies, which was held at the end of May and organized by Raffaele Margotti. The entire TVS MMA community was gathered in person and online to weigh in and draft the best changes to each science case, and also to propose new science cases for the upcoming years. And us SOC members have been working hard on synthesizing these recommendations together into a report, which will be released soon to the community. I wanted to emphasize that this is currently just a draft, and we are really looking forward to all of your input in order to shape the changes to this draft. So also, as Igor mentioned, the 2024 workshop report had many contributors. It was actually led by Igor, Andreoni, and Raf Margotti, and a lot of the changes that we have proposed builds on the hard work that went into this report. So this report succeeded in securing up to 3% of LSST's time for the Target of Opportunity program, and was then endorsed by the SCOC. So now I will talk about the main science drivers that we are proposing for in the 2026 update to this report. Some of these were previously existing in the 2024 report. Some of these are new. So we will continue to have gravitational wave science in there. You can see all of the subcategories in gravitational wave science, including binary neutron star mergers, binary black hole mergers. Now subsolar mass mergers are included, lens binary neutron star mergers. We are now petitioning to include a category for gamma ray bursts, and I will talk about that later in the talk. We will have solar system objects, which is driven by potentially hazardous asteroids, but also includes these interstellar objects, including the one we triggered on. High energy neutrinos, which can have various origins, and other types of rare events, including galactic supernovae, gravitational wave burst events, and gravitationally lensed gamma ray bursts. So I will talk about each of these categories in a little bit more detail, and I will focus mostly on the changes that we have made to the previous recommendations. So I encourage you all to take a look at the previous recommendations, which are available on arXiv, and I'll include a link here in the slides to that as well. So the first category is gravitational waves, and because we have an upcoming observing run with the LIGO Virgo Kagura detectors, specifically here. Let me see if I can use this. Oops. Yikes.
People
I think I did something.
Probably not see the point.
All right, no problem. I will just use my cursor. So here, you can see IR1 is scheduled to begin at the end of this year. We just completed the 4th observing run of the LVK, and we are preparing for the start of IR1. So the recommendations are focused on what we expect for IR1. Because of the sensitivity of the LVK detector network and the uncertainties with respect to Virgo's sensitivity in the network, we are expecting the localizations for gravitational wave events to be very large, similar to what we observed during 04, and thus recommendations have changed to account for this. Specifically, we are petitioning for larger localization areas. And as demonstrated by the past follow-up of Rubin of S251112CM, the subsolar mass merger, you can see here Rubin pointings covering these wide banana-shaped sky maps from that subsolar mass merger event, which happened last November. And you can see that Rubin tile over 800 square degrees in G-band and almost 800 square degrees in I-band in multiple visits on one single night. So it is certainly capable of tiling very wide sky areas greater than 500 square degrees in multiple filters in a single night to a depth of 24th magnitude. So this is a main justification for following up even these coarsely localized events that we expect in IR1. And furthermore, just to remind people why we are interested in gravitational wave science, one of the main drivers is identifying the next kilonova in association with a binary neutron star merger or a neutron star black hole merger. So here you can see model light curves of kilonovae from the POSIS model grid. And here you can see these simulated in multi-filters. So from U to the Y bands. And with our proposed 4-filter strategy in the report, we're able to not just detect, but also characterize the kilonovae at 250 megaparsecs. And even with neutron star black hole merger kilonovae, we're able to detect it and characterize it with at 350 megaparsecs. So the depth achieved in Rubin 30 seconds to 90-second exposure can enable this great kilonova science. I will come back to the question of longer exposures, which is really a question mark for our upcoming run and something that we'd like to discuss further. So the main changes that to the 2024 strategy include, as I mentioned, we will be focusing on more poorly localized events. So we will increase the threshold for triggering on events that are localized to up to 1,500 square degrees, and that is depends on also Rubin's observability window along with the sky map. We have also added a minimum probability threshold of 10%. As I said, Rubin has demonstrated that it can tile these large sky areas. We are also including triggering based on the chirp mass. This pulls in new information that we have received from the LVK regarding the bin chirp mass for gravitational wave events, which will allow us to make a more accurate decision about whether an event is neutron star bearing and whether it is likely to have a counterpart. We also have various changes to the observing strategies to account for the expected template coverage during IR1 and the depth of templates. As I mentioned earlier, we don't know if images deeper than 30 seconds will be possible during IR1 due to the template depth and also due to the technical difficulties with dealing with these longer exposures, as Sean had mentioned. So this is something still under investigation. We have also included high significance subsolar mass merger candidates. As I said earlier, we actually did complete a successful follow-up of a subsolar mass merger during early operations. And this enables us to do some new physics to detect EM emission from subsolar mass mergers of collapsar or primordial origin. So moving on to the next science case, high energy neutrinos. Most neutrino localizations fall within a single Rubin pointing, but the depth that Rubin can reach is far greater than other surveys. And also the high cadence baseline by Rubin provides a very good handle on historical detections and pre-detection limits. So this is a great science case for Rubin that actually doesn't take too much of Rubin's time. So as you can see in this figure here, this is the CDF showing the distribution of neutrino counterparts detectable for Rubin compared to ZTF, and you can see that several more are detectable with Rubin, assuming that neutrinos follow the star formation rate. So the main changes that we are proposing in the 2024 strategy is that instead of triggering on preliminary ice cube alerts, we'll trigger on the initial ice cube alerts. This is because the localization sizes are not differing significantly. We propose to tighten the requirements for aerial coverage, targeting the 90% credible region rather than the 70%. Include neutrino events that have declinations between 0 and 30 degrees, so it's outside the nominal survey footprint, and also propose daily single band monitoring in the strategy for follow-up, which will really aid machine learning classifiers to identify these counterpart candidates, and also include ultra high energy neutrinos into the types of neutrino events that we will trigger on. So moving on to solar system objects, as Sean mentioned earlier, Rubin's first TOO is of the interstellar object 3I Atlas, which is pictured here as seen by Rubin in 21 30-second odd-band exposures. So this was an extremely exciting science case, and of course we will follow up other interstellar objects as well. But one of the driving science cases is that of potentially hazardous asteroids. And Rubin is one of the most time-effective follow-up machines for these objects. Many of these potentially hazardous asteroids would actually be discovered by Rubin first. And that's because Rubin is actually likely to find them at much greater distances from the Earth and probe them much fainter. And triggering on these opens the discovery space to the Southern Hemisphere as well, whereas previous surveys were mostly limited to the Northern Hemisphere. So the main changes that have been proposed here include triggering through the JPL Scout API, or triggering on quantities that are available through JPL Scout, triggering on events that do not have strict requirements on their diameter constraints, so that we can include objects of all sizes that are of interest. Yes, okay, thank you. And lower the probability required. And then also there's ongoing work, as Sean mentioned, to introduce a Kafka stream for the JPL Scout alerts, so that Rubin can automatically ingest them in the way that it does for gravitational waves. So I want to take a moment here to talk about a new science case, which is gamma ray bursts. The main motivation for including gamma ray bursts is that although Swift routinely detects GRBs that are extremely well localized, it's currently not operational. But Fermi tends to detect many more GRBs than Swift and is more sensitive to short GRBs, but the large localizations make it very difficult for other telescopes to conduct a thorough follow-up of these events. So Rubin can actually keep this field alive by localizing counterparts to arcsecond precision and enable a lot of exciting science by providing these arcsecond localizations. The GRB community gathered to define these specific GRB cases. And here's a nice summary figure that Thomas Ahumada provided here, which shows the various GRB science cases that are enabled with Rubin. As you can see, these span short GRBs, merger-driven long GRBs, high energy GRBs, GRBs coincident with the local galaxy cluster, and GRBs that have prompt polarization. So these are a great source of understanding our process enrichment and pursuing kilonova science outside of gravitational wave science. Can get more information about GRB redshifts from Rubin by looking at very high energy GRBs. You can also understand more about extragalactic background light attenuation. And as you can see, there's a lot of science that is enabled by a Rubin trigger of a GRB. And finally, there are some rare categories that we would want to cover as well that would fall within the purview of the Rubin TO Advisory Board. And these include unidentified gravitational wave sources, which include local group supernovae, high mass DBH events, unknown events, as well as lens GRBs and afterglows, and galactic supernovae. So these are many of the synergistic needs that we would that we are petitioning for, that pertain to many of the Rubin TO cases, if not all of the Rubin TO cases that we have proposed for. And this is my second to last slide. One of the main requests is actually to have an early release of templates. This is really important in order to enable the gravitational wave science specifically, but also for other scientific cases to pursue longer exposures. We are asking for dithering between epochs and nights. We are asking also for some flexibility to account for 3% of the TO allocation to be over the entire survey rather than per year of LSST, to account for the uneven temporal distribution of Rubin TOs, specifically driven by the gravitational wave observing runs. And then we have a lot of things that we need to discuss specifically about communication channels with the TO Advisory Committee, enabling the rapid decision making by them, notifying the community promptly of an intent to trigger with Rubin, and also in the event of a trigger retraction. So I will stop there and just emphasize again that this is a draft, and this is something that we really look forward to all of your feedback on. Thank you very much.
Questions for Shreya?
Hi, Shreya. This is Griffin from UC San Diego. What's the rationale for local group supernovae? I would imagine these are already well localized in some of the brightest events, and this is like one of the biggest telescopes.
Yeah. So I had actually included that under the category of gravitational wave burst events in the event that a burst search is triggered by some kind of local group supernova, and this would be prior to any EM telescopes actually identifying that particular supernova. So I think the intention is not for Rubin to follow up things that other small field of view telescopes can easily do.
In the case of maximizing the synergies between multiple facilities that want to do follow-up, how do you plan to synergize with Rubin and other smaller telescopes that are either associated with in-kinds or other collaborators to avoid setting the same target?
Yes, that's a great question. So again, as I mentioned, we have mainly been focusing on these poorly localized events, which require the depth of Rubin. But in order to maximize synergies, one of the proposals is to notify the community immediately after a decision is made to trigger on a particular event. So that would go out in a GCN or in a TNS astronode. The alternative, or after the follow-up has been completed, there should also be another GCN that describes in detail the follow-up that has been completed so that other facilities can complement. And then, of course, alerts will be streamed to the brokers immediately so that people can pick their particular candidates to follow. Yeah.
Any more questions for Shreya?
Hi, Shreya. This is Nandini. Just a silly question. I was wondering why the host galaxy box was white. So why it was separated from the other boxes, but was there a specific reason for that choice?
No, I mean,
okay.
No. Okay.
So could you talk a little bit about what the host galaxy follow-up and characterization plan looks like?
Yeah, so I think the best person to answer this question is actually Thomas. I don't know if he's online here. But I think the plan is actually to conduct the wide field follow-up of GRBs. I mean, to try and tile a very coarsely localized GRB to identify the counterpart. Once the counterpart is identified, there wouldn't be continued follow-up. So this would be left to the smaller facilities, but you could use multicolor information from Rubin to get a photometric redshift potentially, and maybe characterize some of the other galaxy properties in the event that it's not accessible for spectroscopy. Yeah.
Anything online? All right, then let's thank Shreya again. I think we can. Maybe I can have it. Just 1 second to rewire. Good. Thanks, Eric. All right, so in the final bit, about 20 minutes, but honestly, it depends on you. This is a discussion, so there is an active discussion. We get to the end of the hour. If not, we can divert it for lunch. But I think the topic to be discussed is of pretty great importance to all of us interested in Rubin. And I noticed earlier it's not showing full screen. Eric, could you please confirm that people online can see it if I'm not doing full screen, this plot here? Okay, great, thank you. So it's a little bit smaller perhaps, but hopefully everyone can see what we're talking about. As probably all of you are aware, the definition of the survey strategy has been a long iterative process, okay? There was an initial version of a baseline back from, I think, at least 2018 that was developed with the simulation tool, the math, and OpSim, et cetera, et cetera. It's a long history. But the process always worked that a set of possible strategies are simulated, they are fed to the community, diligent students and postdoc crunch the information, they inject their transients and variables or the metrics that they want to get information about, such as the number of galaxies that you can retrieve, and so on and so forth. And then they write white papers, reports to the SCOC, and the SCOC then will make decisions that will inform the next set of simulations. So now we are in a place where this is still happening. I thought it was done, but it's not done. Part of the reason being that there are, well, new ideas, new instruments, such as the DESI spectroscopic facility that came online a few years ago, and some simulations in relation to the science goals that DESI wants to pursue have now become available. But more importantly, the system is built. So the Rubin team had the opportunity of doing all sorts of testing, doing commissioning, and afterwards. And as you probably heard from Bob and Zeliko this morning, the performance is not exactly as we expected it to be. I think what Zeliko was saying, it's only 10% less than expected, which for such a big system is quite remarkable. Now, we're not here to make comments about exactly this 10%, if it's big or small, but I would like this session to focus on what's the impact for TVS and what exactly can we do, if anything at all, as a kind of counter proposal. Not that this is a proposal, I mean, this is how things are. If the efficiency of the system is less, it's less. There is no way around it unless you're a person who's very good with instrumentation. But for example, can we modify the footprint? Can we make a different filter choice, and so on and so forth? The plot that you see here has on the x-axis the latest strategies that have been simulated. This is just a Gantt chart, okay? So on the y-axis, you only you have a number of metrics that have been used to evaluate performance, in this case, compared to baseline version 5.3.1. So if you look, there is one of the latest columns, it's all the same color, okay? This is like the new standard. So if you see blue color, I think, if you see blue color, this means that used to be better. If you see red color, used to be worse, right? This kind of has changed because it's not anymore comparing with the initial baseline and you have only improvements typically from there. But it's like, this is the new standard, this is the new normal. What have we gained, what have we lost? You can see immediately that there is a whole bunch of blue where we like it. Wherever there are, here it's indicated as desk. I've actually borrowed this slide from Federica Bianco. I didn't write the credit, I apologize. This is a combination of work from Fed and from Lynn Jones. What she indicated as desk are metrics that are relevant for the Dark Energy Survey collaboration, but also they're very relevant for TVS. And yeah, things are not great compared to where we were before, but is this actually something to be concerned about? And is anyone here that had the opportunity, anyone here is there that had the opportunity maybe to play around themselves with these strategies And what do you think? I would like to leave the floor open now. Any thoughts? I know it's a lot to digest. So I first appeal to people who have already had a bit of time to digest it, while others take a moment to take in this pretty busy plot. In the meantime, something I can add while people think about how to contribute is that in at least one case, one of these surveys, one of these survey simulations would concentrate all the U-band and G-band observations in the first 2 years of the survey. The rationale is that this will help tremendously getting photoses early, which is good. But there are some setbacks for a lot of transient science. The catch is that this is proposed by the DESI collaboration, and they would offer a lot of spectroscopy in exchange for this compromise. But good luck for anyone who does TDs, for example. I don't know. Any thoughts? Okay, so I see someone has the hand up. So let's start with the hand up and then the comment on chat. Okay. So read it out loud, but if they want
Lucas,
to
do you want me to read the question or you want to ask yourself? Okay, I will read. So Lucas Makiri is asking, I want to make sure I understand this. 5.3.1 is 10-15% worse relative to 5.0.1 in those cells that are in bluish color.
Yes.
Yes, right.
Right.
You understand correctly.
I think it's right, but everything is much harder when you're the person standing with a whole bunch of folks in front. So if anyone with more current brain power than me wants to double check, that's always something I'm grateful for. Okay, Sahana, would you like to unmute and say some thoughts?
Yeah, sure. Thanks, Igor. Hi, everyone. I'm Sahana Kumar. I'm a postdoc at University of Virginia. And this past week, we've been gathering TVS feedback specifically on this proposed DESI-Rubin data exchange and have been compiling a document basically talking about the potential effects of a gap in UNG band coverage on the various science cases that TVS members are interested in. This document can be found on our Slack channel, on our main TVS channel, and we're just doing a Google Doc listing out the possible effects. We're mainly just focusing on how certain types of science can be impacted by a gap in UNG band coverage, and if any science can be recovered by the intern spectroscopy that DESI has offered the Rubin community. I did want to mention that a lot of the scientific impact that we're discussing on this document is very much assuming that some portion of the spectroscopic time offered by DESI will be devoted to transient or time domain science. And we see some potential for scientific return thanks to the resolution of DESI's spectrograph and their capability of returning produced data products within a short period of time, which could be very beneficial to the transient and time domain community. On the other hand, based on the information we've gathered so far, some of the time domain areas could be drastically affected by gaps in U and G band coverage. Definitely gaps in G band coverage affect the ability to detect and identify new transients and may bring certain types of transient science to a screeching halt during that time. So for now, we would love to continue to gather more TVS feedback on this. I see folks have been adding things to the document today, which I'm very happy to see about. If you have thoughts, please do add them either by typing directly into the document or you can leave a comment. We do have kind of an ongoing discussion on the Slack channel as well. One challenge that's come up this week is, again, because some of the details of this proposed change to the overall strategy, we don't really know yet, how this might affect it. So we're keeping it very broad of just what would happen if we lose some UNG band coverage, and then what can we gain if we can use DESI spectroscopy to follow up Rubin transients. So please continue to add your thoughts to this. One thing I did want to mention, kind of from the supernova time domain transient side, is that if there is a concern about how to implement follow-up spectroscopy, there's already a lot of community infrastructure built in place, and that's sort of the logistics of that is something that is commented upon in this document. So I'm hoping this week when we're at the RCW, both in person and online, to have some conversations about how, what are the ways that this could possibly done to serve multiple areas of science while mitigating some of the potential negative impacts. And we're hoping we can just make sure that we compile all this information for our SCOC liaisons to be able to communicate to the Survey Cadence Optimization Committee on how this will impact TVS's various science areas. And yes, thank you, Rachel, for posting the doc in the chat if you'd like to take a look at it.
Great. And from the point of view of supernovae, besides being a little bit kind of above the individual case judgment, since you're kind of putting together this document for everyone, do you happen to have any strong opinion that you would like to voice, or are you still in phase of studying the pros and cons?
Yeah, so from the supernova point of view, we definitely see this proposed DESI Rubin data exchange as one possible way to mitigate some of the losses to time domain science that are happening. I think the main return for supernovae has to do with the high resolution of DESI's spectrograph. There are some subtypes of supernovae that have very narrow features, and being able to resolve them at early times can be challenging with some of the other sort of community follow-up efforts out there. So we see this as an opportunity to maybe finally get spectroscopic data for a rather underserved portion of the supernova population, and with the hopes that, with part of this data exchange being that it will be released to the whole Rubin community. This is sort of a gap in the supernova field that we think could be greatly bolstered by this program. But of course, we want to make sure we account for what we, also might lose in having these gaps in UNG band coverage. This is why part of the TVS recommendations, again, are very contingent on part of the DESI spectroscopic time being devoted for time domain follow-up.
I just had a clarifying question. Sorry, this is Natasha Abrams. And is it determined what the footprint of the DESI follow-up would be even for the time domain science? Would it all be extragalactic supernova type follow-up or also galactic science?
From my understanding, there is some, I think, already predetermination of the footprint. Again, because DESI's in the north, they're kind of equatorial fields. There was a plot shown in the SCOC meeting. Perhaps we can find that. But to my knowledge, that there is some. We have an idea of what the overall footprint would be, but I am not sure if there's already any determination of which fields are going to be more extragalactic, which ones are pointing more towards the galactic bulge. That I'm not sure about, but if somebody else in the room or online has more information, please chime in.
Does anyone? Because if not, I would just say that DESI has 5,000 fibers for galaxy, and they would spare about, 200 for transients. So I don't know if they would look too much through the galactic plane with all the fibers, but to be fair, I don't know for sure. This is very much speculation. Any more thoughts about well, what are we losing by losing 10%? And is it something we can just cope with and that's it? Or should we try to come up with ideas to propose to the Rubin leadership to mitigate problems, for example, for fast transient discovery? Because this 10% also something that some of you might have seen is that, well, if you lose 10% over a 10-year survey, just add 1 year, done. And that's not a bad idea per se, of course. The problem is the cadence will not be recovered. So if you do very long duration transients and variables, then it's easier. Otherwise, it's going to be more complicated. So, okay.
That's what I was going to say. Just that 1 extra year doesn't help us.
Say it in the mic, and then we pass to Katie.
I was going to say just exactly what Igor just said, which is that, you know, it's obvious to us, but it does need to be stated explicitly that 1 extra year at the end does not make up for the cadence being slower for fast transients, because we just simply won't find as many of them, even if you add another year.
Katie.
Hi, everybody. This is Katy Vivas from Noid Lab, and I'm wearing my hat as a member of the SCOC. I just want to clarify that the 10% loss is due to the increased engineering time, not to the DESI. I mean, DESI will change the cadence in U and G, but the 10% is something that is there, and it's something that we cannot do anything because it's just downtime for the extra engineering that the project had to plan in consequence. So not to confuse the two things. The 10% loss is there, is going to be there, nothing to do. Now, on top of that, there is a special simulation for the DESI, for this DESI exchange that will increase the cadence in U and G in the northern declinations. Probably, I don't know if somebody has that. I don't have it at hand, the footprint. So it will increase the cadence in U and G at northern declinations. Of course, at the expenses of it will change the cadence in those filters, and in consequence, it will change the cadence in others. But the I mean, my main point was that not to confuse that the 10% is due only to the DESI, because it's not. The 10% loss is due to the increased engineering time. That was my point. Thank you.
Thanks, Katie. Yeah, that's been there used to be some confusion about this in the last couple of months, but yeah, it's good to remark one more time that this is the case. It's just this 10% we can't go around really. Any more thoughts or responses to anything you've heard so far?
Thanks, Igor. This is Nandini. So since a lot of the kilonova detection and characterization was anchored on the G band, has there been any fast turnaround in sort of determining what other band it will then be anchored to, or if at all it can be done? Does anybody have any thoughts on that?
I don't really know why you're looking at me. I guess I looked at you. There's a little bit of discussion about that in the document, but I think that was all like over the weekend. So there's definitely stuff to figure out if that's possible.
And as a reminder, this DESI proposed strategy is one of a few that are still being evaluated. I think it's just the one that maybe would imply more differences compared to what we are kind of used to. And that's why maybe it's the one that is most discussed. But yeah, so missing G-band can have consequences for sure, but with advantages. Anything from online? Well, if not, happy to give you back 5 extra minutes of lunchtime. And thank you all for coming today and participating. And thanks to all the speakers again.